Hello everyone, today let's solve the problem fire again, right? So this was asked in the Codeforces beta round division 2, right? So you can just go through the question, it's easier to understand and I'll just summarize the question so that it will be easier for us to solve the problem. So input we have to take in input.txt, they have mentioned here, and the output that we need to output via this one, output.txt, txt file, right? So this is fine, I believe, don't get confused. So now let's see what the question states here. Just give me a second, 1 second. Yeah, 1 second, just give me a second here. Yeah, so now we have been given a n into m grid of trees, right? So we have been given n into m grid of what we have been given, trees basically, right? So we have been given n into m grid of trees. So fire starts simultaneously at k given cells. Fire starts immediately or simultaneously, sorry, fire starts simultaneously at k given cells, every minute fire spreads to all the 4 neighbor cells. Every minute fire spreads to all the 4 neighbor cells, left, right, up and down, right? So every minute fire spreads to all the 4 neighboring cells at the Manhattan distance 1, right? So this is very important. Every minute fire spreads to all the 4 neighbor cells at Manhattan distance 1, right? So that they have mentioned in the question correctly, that are not burning. Every minute fire spreads to all the 4 neighbor cells at Manhattan distance 1 that are not burning, right? Where it's not burning, the fire spreads there to all the 4 neighbors. And we have to, what we need to do, we have to find the coordinates of any tree that starts burning last. So what we need to do, we have to find the coordinates of any tree that starts burning at last, basically. So we have to find this one, coordinates of any tree basically, right? So coordinates, so I'll just write here CORD, coordinates of any tree that starts burning last, So this is the question basically, simple one, right? So we have been given an n into m grid of trees. The fire starts simultaneously at this one, k given cells, right? So at every minute fire spreads all to all the 4 neighbor cells at Manhattan distance 1 that are not burning, right? So what we need to find here, we need to find the coordinates of any tree that starts burning last. Basically we need to find the coordinates of the this one, any tree that starts burning last, right? So this is the question, this is simple, man. Let's get into the this one, input output part, right? So we have been given here nm basically, right? So just give me a second, 1 second here. Yeah, so here nm we have been given, so n into m grid we have been given, right? So this is 3 into 3 grid. This is nothing but, sorry, just give me a second here. So yeah, this is nothing but n and this is nothing but m here, and k we have been given 1 here, nm k we have been given 1, and start we have been given 2 comma 2, or 2 and 2 we have been given, right? So this is nothing but fire starting, right? So this is start 2 comma 2, and the output that we need to get here is 1 1, right? So output that we need to get here is 1 1. Let's see what happens here, right? So n we have been given 3. This is 3 into 3 grid, because we have been given an n into m grid, right? So 3 3 we have been given n and m. K we have been given 1, and start is 2 comma 2. The output that we need to get here is this one, the coordinates basically, right? So the coordinates at any tree, so in the question they have clearly mentioned, right? So we have to find the coordinates of any tree that starts burning last. So the coordinates of any tree that is burning last here would be the coordinates 1 comma 1 basically, right? So 1 comma 1. So this one, let's consider the same example for the approach so that we understand how we get the output 1 comma 1 as well, along with the crystal clear explanation, right? Same goes with the example 2 and input 2 and input 3, or example 2 and example 3, right? So let me delete this one. This is about the question. So let's do one thing. We are done with the question part and the input output part. Let's discuss the this one, approach first, followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So here we have been given example 1. Sorry, I have considered example 1, right, as we discussed. So we have considered example 1 for the approach. So we have been given n3 m 3 and k equals 1, start we have been given 2 2, the output that we need to get here is 1 1, right? So this is fine, this is the coordinate basically, right, that starts burning last. So the approach that we'll be going with here is BFS. To solve this problem, we'll be making use of the BFS, or the breadth first search, right? So this is fine, I believe. Next, let's move on with the step-by-step explanation. As I have said, we'll be making use of the BFS, right? So we'll be using multi-source BFS. Again, I'm repeating this one. We'll be using multi-source BFS. First, what we'll do here, we'll push all the k starting cells, right? So k, in our case, in the example, they have given 1. We will push all the k starting cells into the queue with the distance 0. They have mentioned in the question, if you remember, every minute fire spreads to all the 4 neighbor cells at the Manhattan distance 1 that are not burning, right? So here what we will be doing, we are pushing all the k starting cells into the queue. This is fine. In our case, in the example k, they have given 1. We'll push all the k starting cells into the queue with the distance 0 initially and run the BFS, right? What does BFS do? BFS visits the cell in the increasing time. BFS, what it does? BFS visits the cells in the increasing time, nothing but increasing time in the sense distance, right? So the last popped cell is the one that burned the last. So the last popped cell, the last one, right? So the last popped cell in the BFS, basically we'll be making use of the queue within the BFS, right? So the last popped cell is the one that burns last. So that will be the answer basically in simple terms, right? So now let's implement the same thing on the example 1 basically. So n we have been given 3, m3, k equals 1, and start we have been given 2 comma 2. This is the first example that we consider, right? Initially t will be 0 and q will be 2 comma 2. Start we have been given 2 comma 2, right? So we'll be considering start 2 comma 2 as well. Initially in the queue, as we are going with the BFS, we'll be making use of the queue, and initially it will be 2 comma 2, and t we have been given 0, right? So t we have 0, sorry. And what we will do first, we will pop 2 comma 2, right? We'll pop first 2 comma 2, and we will be enqueuing the neighbors 3 comma 2. We'll be enqueuing the neighbors 3 comma 2, right? So this one will be 3 comma 2, 1 comma 2, 2 comma 3, 2 comma 1 with t equals 1. What we'll be doing, we'll enqueuing the neighbors 3 comma 2 along with 1 comma 2, 2 comma 3 and 2 comma 1 with this one t equals 1. You can just write this one in kind of matrix table and you can just check, right? Start with the 0 comma 0 and you can just check if you want to, right? I'm doing this one directly, right? So we are popping 2 comma 2 first, because in the start we have been given 2 comma 2. So what we'll do, we'll pop 2 comma 2, we'll enqueue the neighbors 3 comma 2, 1 comma 2, 2 comma 3, 2 comma 1 along with when t equals 1. Initially t was 0, and when t is 1, we are popping 2 comma 2 and we are enqueuing the neighbors, all of its neighbors, right? So whether 3 comma 2, 1 comma 2, 2 comma 3 and 2 comma 1. I have checked, you can just check if you want, right? So next step, what we'll do, first we are enqueuing the neighbors 3 comma 2. The first this one we have here as cell we have here as 3 comma 2. So what we'll do, we'll pop 3 comma 2. This time we will be enqueuing all its neighbors, right? So we will enqueue 3 comma 3, 3 comma 1 with t comma t equals 2. So previously t was 1, we are going with the t equals 2, right? So now we are just enqueuing the neighbors of 3 comma 2, that is 3 comma 3 and 3 comma 1. So this one, right? So now we have this one, what do we call? Now we have 1 comma 2. So we have to go with popping 1 comma 2, right? So just give me a second, did I get confused here? All right. So this is fine. Now we have 1 comma 2. So we will be popping 1 comma 2. So now we'll be popping 1 comma 2. So what we'll be doing, we will be enqueuing its neighbors, nothing but 1 comma 3, 1 comma 1. So previously t was this one equivalent to 2. Now also it will be equivalent to t equals 2. We are considering when t equals 2 itself, right? So this one will be when t equals to 2, we are popping 3 comma 2 and 1 comma 2. So that is the reason we are not considering 3 comma 3 next, right? So here we are popping 3 comma 2 and enqueuing 3 comma 3, 3 1 and 3 comma 1 with t equals to 2. We are going level by level, right? So we will pop 1 comma 2, another one. So we will enqueue its neighbors 1 comma 3, 1 comma 1 with t equals to 2, t equals to 2. So this is fine. So we will continue popping in the same order. So the final popped cell is 1 comma 1. So final popped cell is 1 comma 1. So the answer sample is 1. The answer sample here is 1. So we need to display the coordinates in the output. So what we'll do, again I'm telling, we'll continue popping. This one we have done, right? So this one, 1 second, this step actually, this step, right? So in the fourth step, so this step similar to this one will continue popping in order. So what we'll do, final popped cell will be 1 comma 1. So as per the discussion here, see what we said, BFS, after applying the BFS or when we start the BFS visits the cell in increasing time. The last popped cell is one that burns the last, and in the question they have asked us to display the coordinates of the cell that this one that burns last, right? So here in this case what we'll be doing, so this is the coordinate basically. We, after continuing popping in the order, continuing this one popping basically in the order, the final popped cell is 1 comma 1. This is nothing but coordinates, right? Coordinates. So answer is sample 1 basically. Answer is sample 1, and we need to display the coordinates in the form of output, right? So this will be the output basically. 1 comma 1 will be the output, right? So we need to display this one, 1 and 1, right? So here what is the key? BFS, what it does, it processes layer by layer or level by level, right? Storing the last popped cell that gives one valid last burning tree. So that is how we got 1 comma 1 here, right? So the final output that we got here is 1 1, which is equivalent to the output that they have shown for the example 1 within the question. Example 1 within the question. See here, 1 1, right? So the output that we got here is 1 1, which is equivalent to the output that they have mentioned for the example 1 within the question. Easy, right? So this is basically easy to medium question. So the output that we got here is 1 comma 1, which is equivalent to the output that they have mentioned for the within the example 1, right? So our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity and the space complexity here? The time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m and big of n into m respectively. So why the time complexity here is big of n into m? Because every cell is being visited at most once here, and each edge, when I say each edge, I'm speaking of the 4 neighbors, right? 4 neighbors is checked a constant number of time. So overall time complexity would lead to big of n into m. They have given in the question that fire spreads to this one. Once it starts, fire spreads to this one, all the 4 neighboring cells, right? Which is not burning basically at that point of time, right? So that's what they have given in the question. So every cell is visited at most once, and each edge, nothing but the 4 neighbors, is checked a constant number of times. So overall time complexity would lead to big of n into m. So what would be the space complexity? The space complexity would lead to big of n into m as well, because we'll be making use of the distance array of size n into m, and also q, because as we are making use of the BFS, we'll be going with a q that in the worst case it can hold big of n into m element. So overall space complexity would lead to big of n into m as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m and big of n into m respectively, right? So now as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. I'll just come here. So now we'll be making use of the fast input and the fast output, right? So let's import the input output package here. This is fine. Also we'll be making use of the different utilities as well. I'll just go with util.star. So this is fine as well. So let's consider the class here. I'll just go with main as usual. You can just give any class name that's relevant to the question, right? So you can just give the question name itself if you want. This is fine. First within the main this one class main, so we have to go with the movement offsets for the 4 neighbor cells, right? So whether it may be up, down, left and right. So I'll just go with here static. So this one int dx equals, so this one will be 1 comma minus 1 0 comma 0. This is fine. Yep. Now also static, so this one will be int dy equals 0 0 1 comma minus 1. This is fine as well. Yep, we are done with this, right? So we have just went with the movement offsets for the 4 neighbor cells, down, up, right and left, or up, down, left and right. This is fine. Now let's go with the main method, right? So this one, delete this one, and also let me include throws input output exception. So this is fine. Now within the main method, the first thing that we will be doing here is we will be going with the buffered reader and the print writer. So that is the reason we have this one imported input output package, right? So one thing here, so in the question they have asked us to go with the, for the input they have asked us to go with the input.txt, and for the output they have asked us to go with the output.txt, right? So let's do one thing, let's make use of this one, input.txt and output.txt within the input and output. So I'll just go with buffered reader here, br. So this one will be new buffered reader. Instead of the new input stream reader, what will be making use of file reader, right? So we are going with a file input.txt, right? So let's make use of the file reader here. So this one will be input.txt. This is fine. Same thing, let's do this one for the, let's do the same thing for the print writer as well, I mean for the output basically in simple terms. So this one will be pw will be new print writer. So this one will be new, instead of the buffered reader let's go with the buffered writer as we are dealing with the output. So this one will be new file, instead of the file reader this will be file writer of, let's go with the output dot text. So we are using it because they have asked in the question strictly basically, right? So this is fine. Now we have to read first line, nothing but we have been given n into m, right? So nm, sorry, not n into m, basically this one nm, this one we have to read. Then we have to read this one, this is nothing but the k, and then we have to read the start as well. So let's do that. So here first we have to read nm, right? So I'll just go with the string, we consider variable s buffered reader dot, so this one will be read line, as we are making use of the buffered reader. Also let me make use of the split here. So because we have space between the elements, right? See here 3 3, we have the space between elements, so let me make use of the split and leave the space. This is fine. Now we have to pass the number of rows and number of columns, right? So I'll just make use of n and m. So this one will be, both are of the type integers, right? So this one will be integer dot parseInt. So this is fine. So this one will be s of 0 comma this one m equals integer dot same thing parseInt of, so this one will be s of 1. This is fine, I believe, right? So now we have to read the second line which contains k. We have k, this one, and then we have start 2 comma 2. First we have to read k, right? The second line. So this one will be k equals, which is of the type integer, again integer dot parseInt. So this one will be buffered reader dot read line. This is fine. Next one we have to read the third line, which consists of 2 into k integers, right? So this one is x1 y1 x2 y2, in that format they have given in the question, right? So this one will be string. In simple terms we are going with the start, right? So this one is p equals where the fire starts burning, right? So this one br dot read line, buffered reader dot read line, and we have space here between, see x1, after x1 for the y1 we have space, for we can see here x1 y1 x2 y2, we have space between the elements, right? So let me go with the split again here. Split is slower actually, so it's better to go with the tokens, this one string tokenizer, but for this particular problem it works. So let's make use of the split itself, right? So let's go with the split. This is fine. Now let's do one thing. Let's go with the distance array. So they have mentioned that this one Manhattan distance, right? So let's go with the distance array. Nothing but d of ij equals minute when tree I comma j starts burning. So here -1 means unvisited, right? So let's initialize the distance d first. So this one will be d equals new int of size n and m respectively. So this is fine. So now what shall we do? Let's initialize all the distance to -1. Initially every cell is unvisited, right? So let's initialize all the distances to -1. So let's make use of the for loop here, and row distance d. So let's fill this one with -1. I'll just make use of arrays dot fill row comma -1, right? So this Java and JavaScript is very similar, man. I won't lie. Java and JavaScript is extremely similar. So row comma -1. This is fine. So let's make use of the queue for BFS. Each element is an int of this one x comma y. So we'll be going with a 0 based indices. Just remember this one. Don't forget this one. We'll be going with a 0 based indices. Let's in simple terms for now, let's go with a queue for BFS, right? So as we are making use of the BFS, we'll be going with a queue, right? So this one will be int, yep, q equals new array dq. So this is fine. Yep, this is also fine. Now let's do one thing. Let's read all the k starting points and push them into the queue with the distance 0. So this one will be for and I equals 0, I less than 2 into k, I equals I plus 2. So within the for loop, the first step is we have to convert this one to the 0 based index. Let's consider variables x and y. X equals, so both are of the type integer, right? So this one will be integer. We have to pass this one. We'll be making use of passant. So this one will be p of I minus 1. So this one has to be whole. We have to consider minus 1, right? So for the y, it will be same thing. Integer dot %. So for the y, it will be p of I plus 1, the next element, right? So this one will be I plus 1 whole minus 1. So this is fine, man. So the next step would be here. We have to add this one to the queue as starting burning trees, right? So this one for adding, I'll just make use of the add operation, new int of this one x comma y. That's what we discussed, right? So this one, let's write this one in the flower brackets, x comma y. Now let's mark as visited at the time 0 d of x y. So this one, let me assign this one to the 0, right? So let me come out of this one entirely. Now what shall we do? So let's go with the array to keep the last popped cell from the BFS. So this will be the last cell that starts burning basically, right? So we have to go with the array. So I'll just go with the variable name last here, and let me initialize this one with new int of size 2, right? So size 2 is enough basically. This is fine. Now let's go with a standard BFS loop. Q as usual. So I'll just leave the line. So while not of q dot is empty. Same thing, right? So we will remove front cell first. So this one will be int and this one current equals q dot, sorry, let's make use of the poll operation the queue provides basically, right? So this is fine, man. So we are just removing the front cell. So to remove the front cell, we are making use of the poll operation, right? So that the queue provides. So I'm going with a q dot poll, right? So this is fine. So the next step would be we have to update the last to this one current popped cell, right? So let me assign last to current here. This is fine. Now let's try all the neighbors, man. This is going to be the main step. We have to try all the 4 neighbors, right? Up, yeah, up, down, left and right. So I'll just go with the, instead of the recursion, let's go with the iteration basically, right? So let's try all the 4 neighbors. So this one BFS uses, so we'll be making use of iteration itself, right? Not the recursion basically. Int I equals 0, I less than 4, I plus plus. So within the queue, so what we'll be doing here, first step would be, let me go with nx equals current of 0 plus dx of I, so this is fine, ny equals current of 1 plus dy of I. This is fine. Now let's check the bounds and whether neighbor is unvisited, right? So now let's check the bounds and whether neighbor is unvisited, right? So let's go with the simple if condition here. If nx is greater than or equal to 0 and ny is greater than or equal to 0, and so this one, we are just checking the bounds, right? Nx, it shouldn't be less than n, and also ny, ny shouldn't be less than m as well, and distance of nx, and we have considered ny, variable ny, right? Yeah, nx and ny. So if it is equivalent, it shouldn't be equal to -1 as well. If it is equivalent to -1, then what we will do, we'll set the distance to the parent's distance plus 1, right? So we are going with a minute when it starts burning, right? So this one will be d of nx, distance of nx and y. We are setting the distance to the parent's distance plus 1, right? So this one will be distance of, within the array, current of 0, this one, right? So I'll just go with a current of this one, 1 basically, plus 1. As I've said, we are setting the distance to parent's distance plus 1. This is fine. Finally, we have to push the neighbor into the queue. So for this one, I'll just go with a add operation. So q dot add new int. So this one will be nx comma ny. This is fine. Yep. I didn't have closed this one here itself. So let me remove this parenthesis and let me close this one here, right? So this is fine. Now let me come out of this one entirely. We are done with the logic part. So we are left with this one input output part. We have to print the answer converting back to the 1 based coordinates, right? So we had used 0 based actually, 0 based coordinates. So now we have to print the answer converting back to the 1 based coordination or coordinates basically, sorry, and then we have to close the writer, means we have to flush the output. Either we can make use of the flush or close for that. First let's print the answer converting back to the 1 based coordinate. So this one will be print writer variable, we have made use of pw. So this one will be println. So this one will be last of 0. This is fine. Plus 1. Yep, this is fine. And we need to leave the space. We have the space, right? So again, last of the coordinates we have to display, right? So this one will be, let me make use of the parenthesis over here. Last of 1. Let me go with plus 1 here. Simple. Right, so here something I have done wrong, man. I don't know what I have done wrong. Last of 0 I have considered here, and so let me do one thing. Let me consider one more parenthesis here so that it will not be wrong, right? So this is fine. Finally, let's close the writer, means we have to flush the output. So I'll just go with pw dot flush or close. I'll just go with a close, either of them works, right? This is fine. Yep, we are done with the coding part. So before checking the code with the different this one inputs or the examples, let me copy paste the signature starter template. Just give me a second here. So I'll just come here, let me paste this one over here. So this is fine, man. I'll just come to the problem. See, let me copy this one. The output that we need to get here is 1 1, right? Oh yeah, this one I have done wrong. Line number 39 bracket. So p of I, so this one has to be p of I plus 1 square bracket. So we have one more error here. What is this error? Oh yeah, p of I plus 1. I have to remove this one. So we are going with p of I plus 1, the next one. It has to be within the basically square bracket, sorry. Yeah, now we have one error, two errors basically. Error semicolon expected, where, oh, that is int nx. We shouldn't be having any space there. Line number 50. So this is nx, single variable. Java data 8 file not found input. Oh yeah, we are going with this one, right? So we have cleared all the inputs. For this particular one, they have asked us to go with the input.txt and output.txt. So we cannot see this one with the online compiler. So I'll just copy this one. We have cleared all this one, right? So let's directly submit, right? So we have cleared all this one, right? So yep, let me submit the code for this one. This is C, right? Problem C, yeah. Paste the code over here. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Because they have asked us to give the make use of input.txt for the input and for the output.txt. We cannot check the file, this one, input.txt file and output.txt file within the compiler, on compiler. So that is the reason it is showing error. Let's directly submit this one. We have already submitted, right? So this is fine. 1 second. Yeah, this is running on this one, test 47. So see here, the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. So we have made use of BFS here, right? So pure BFS with the along with the queue. So whenever we make use of the BFS, we'll be making use of the queue itself, right? So here, standard BFS loop here, while queue is not empty, you can see we are making use of the queue. Basically, we are going with the BFS, right? So I hope the solution part is completely clear along with the approach and the complexities, right? So this one was the easy one, I wouldn't lie. So for now, this is it. Thanks for watching, guys.